Hey everyone, so if you've ever spent weeks, maybe even months in the lab, just tweaking one little variable at a time and hoping, just hoping, for some kind of breakthrough, then you know exactly how frustrating that can be. Well, you're in the right place. Today, we're going to talk about a super powerful method called design of experiments, or DOE, that's all about getting you better results, way faster. So let's jump right into the big question, the one that trips up a lot of us when we're starting a DOE. Should I use a screening design or should I use a response surface design? They sound kind of similar, but trust me, choosing the right one at the right time is absolutely critical. And this isn't just some academic debate. Picking the wrong tool for the job can literally send you down a rabbit hole for weeks, burning through time, materials, and just a lot of energy. So let's make sure that doesn't happen to you. Okay, first things first, let's make sure we're all on the same page with a couple of key terms. First up, a factor. A factor is simply any input that you can control in your experiment. The best way to think about it is like a knob you can turn up or down. Things like temperature, the concentration of a chemical, or how long you let something incubate. Simple enough, right? So if factors are the knobs you get to turn, the response is the result you get to measure. This is the output you actually care about, the thing you're trying to improve. It could be the signal-to-background ratio in your assay, the precision of a measurement, or just the overall performance of your system. It's your goal. All right, now for the big idea. The one thing that, if you remember nothing else from this, will make it all click. The absolute best way to think about the difference between these two designs is with a camera analogy, a wide-angle lens versus a zoom lens. Screening? That's your wide-angle lens. You use it right at the beginning when you've got a whole bunch of possible factors, and you need to figure out which are the heavy hitters, the few that actually matter. Once you've found them, you switch to your zoom lens. That's the response surface design. This is for fine-tuning those critical factors to find their absolute best settings. So you see, they're not competitors, they're partners. It's a 1-2 punch. So let's dive into phase 1, screening. This is where we pull out that wide-angle lens to cut through all the noise and find out what's really driving our results. So, when do you need this wide-angle lens? Well, a screening design is your best friend when you have a long list of potential factors. We're talking 5 or more, and you're just not sure which ones are the ones to focus on. The whole point here is to stop wasting time on the maybes and efficiently narrow your focus. Now, this slide points out a classic mistake. If you set your low and high values for a factor way too close together, you're just not going to see a big enough change in your response. And what happens then? You might accidentally conclude that an important factor doesn't matter at all. So remember, screening is just about pointing you in the right direction. It is not the final answer. Okay, so our screening phase did its job. It's identified our key players. Now it's time for phase 2, response surface. Let's switch over to that zoom lens and get ready for some precision fine-tuning. This quote just says it all, doesn't it? For so many things in science, it's not a simple case of more is better. So often there's a Goldilocks zone, a sweet spot, where performance is just right. Too little is no good, but pushing it too far can be just as bad, or even worse. Response surface designs are built specifically to find that peak. So you bring in the zoom lens once you've narrowed your focus down to just 2 to 4, maybe 5 key factors. Your goal here is to map out the optimal region. And this is so important because you want to find a robust zone of good performance, a range of settings that works reliably, not some single fragile little point that's going to fail the second conditions change just a tiny bit. And of course, there are pitfalls here too. The single biggest mistake, hands down, is jumping straight to a response surface design without screening first. You risk spending all this effort optimizing the wrong factors. And another key, like we just said, is to aim for the best region. A method that only works at one hyperspecific point is a method that's pretty much doomed to fail in the real world. This table just pulls it all together so nicely. Just look at the contrast. Screening asks, which knobs matter? Response surface asks, okay, where is the sweet spot for these knobs? Screening looks at many factors with simple low/high settings. Response surface looks at just a few, but adds a midpoint to really map out that optimal zone. It's a beautiful, logical progression from broad exploration to focused optimization. So let's put it all together into a workflow you can actually use. This is how you go from a confusing list of a dozen variables to a robust, reliable method that just works. Here it is, a simple 4-phase recipe. Start with a quick feasibility check in what we'll call phase 0. I mean, you gotta make sure the basic idea even works, right? Then phase 1, you screen to find your key drivers. Phase 2, you use that response surface design to find their sweet spot. And please, please do not skip phase 3, confirmation. This is where you double-check that your new settings can handle all the small, real-life variations that are gonna happen every single day. And here's the bottom line. DOE isn't about running more experiments, it's about running smarter ones. Instead of those endless weeks of changing one thing at a time, a well-planned DOE can give you massive insights from just 2 focused rounds of work. It is an incredible accelerator for your projects. So really, the question isn't if you should use these tools. The question is, what process, what assay, what experiment are you going to optimize first? With this structured workflow, you're now ready to get to your best results faster and more efficiently than ever before. Thanks so much for tuning in.